Hey guys, welcome to part 32. This is on DP203 Azure Data Engineering. So if you are not yet subscribed, do so. This will help you with clearing your Azure, AWS Cloud, and Google Cloud certifications. So you have a Azure Databricks workspace. It contains a Delta Lake Dimension table, table 1. If you want to operate with big data, lots of data, then you use Azure Databricks. Databricks is a separate product, but Azure Databricks is an extension of the same product. Okay, so you're trying to create a Delta Lake dimension table. If you are wondering what is Delta Lake, it is a optimized storage layer. You can connect to Parquet data files. Okay, now table 1 is type 2 story changing dimension. So this is type 2 SCD, and you need to apply updates from a source table to this table. So you have this source table, this is S source table, and you have to apply to this big table. This is table 1. You have to provide updates from this place to this place. And which Apache SQL operation will you use? You all know in the big data world, you need to know Apache Spark. Apache Spark is used for coding. See, in this case, we will have to use merge operation. See, merge operation in Apache SQL is used to upsert data. Upsert means insert. If the data does not exist, it will insert. If the data exists, it will update it. Okay, and the merge operation takes 3 arguments: the source table, the target table. So in our case, this small table will be the source table, this big table will be the target table, and then we will have to provide the merge condition. The condition can determine how the data from the source table will be merged with the target table. Okay, and if you want to understand Delta Lake dimension tables, this is your Delta Lake description. What is Delta Lake? It has ACID compliance. ACID means like if I update the table now, you can see it immediately. That is ACID compliance, and it is working well with unified streaming and batch processing also. So merge would be our answer. Let us look at this next question. This is a Azure Synapse Analytics question. So in the Azure world, for data warehouse solution, remember, for data warehouse, use Synapse Analytics. So in this case, they are using this pool, and it contains one table. So you have one big database, Synapse Analytics database, and inside this database, it has one table called table 1. It contains 1 billion rows, lot of rows, 1 billion rows, clustered column store index, hash distribution on product key, and the column name sales data that is of data type cannot be null. Okay, 30 million rows will be added to this table every month. Today it is 1 billion. Today it is 1 billion. Every month 30 million will be added more. So next month it will be 1 billion and 1.3 billion. After that it will become, after 2 months it will become 1.6 billion, like that. You need to partition the table based on the sales data column. The solution must optimize query performance. So this is important. You should optimize query performance and data loading. How often should you create a partition? Now immediately you might bounce and say, hey, let us create the partition every month, because it is talking about 30 million rows every month. I will save the data every month. Okay, is that so? So that is not the logic. If you see here, you will need minimum 1 million rows per distribution. Each table has 60 distributions. 30 million rows is added each month. So need 2 months to get a minimum of 1 million rows per distribution in a new partition. So that is why we will have to use the partition at year level, not at month, week, or day level. It will be very short. It will has to be at the year level in order for a query to perform well and the data loading also to work faster. So again, this is a Synapse Analytics question. You need to create a table. The table name is fact. So this is a table, and this is called fact intelligence. It's a large fact table with a dimensional model. So it is a star schema probably, and this cells will contain 100 million rows. So this has 100 million records. So lots of data is there, and it has two columns: sales amount and sales quantity. Queries executed on this will aggregate the values. So what it will aggregate is sales amount. If there are 10 rows, it will aggregate to one row, and it will aggregate these values. It will roll up. The solution must minimize the data size and query time. How should we complete the code? So they have given this code, and they are telling us that first please complete the code. This is also a portion of the question. So they want us to complete this code. So in the with clause, what should be used? In the distribution clause, what should be used? See, when the roll up will happen, you will have to rule the roll up on what? See, if you see here, the roll up has to happen on the product, because for that product, what is the aggregate sales amount, what is the aggregate order quantity, it will tell you. So in this case, the roll up has to happen at the product. So distribution has to be at the hash product key, and then with what? With clustered column index, order key. What should be used? It should be clustered column store index, because this is the way it will running faster. That is what we have to do. We have to minimize the data size and improve the query execution time. Improve the query execution time means you need very high performance. So if you have not yet subscribed, do so. It will help you with Azure, AWS, Google Cloud certifications. there are a lot of contents in the paid group. Become a cloud kernel cloud ninja member. Boss, become a cloud kernel cloud ninja member, gain access to those components, to those questions. There are a lot of important questions. It will help you clear the certification. This brings us to the end of part 32. See you in the next part.